So our second presentation is from Dan Cayan, who is also from Scripps Institution of Oceanography. And I may be butchering the full range of what Dan does, but he's interested in predicting climate changes and looking at historical record as well. Is that fair enough or close? It's close.
I'm certainly interested. Whether I'm successful is another question. It's good to be with you, and this is an interesting forum that has been established here. Probably it's useful to know where I come from. My career was really built on looking at natural climate variability, that is the sorts of variations that we all have seen at relatively shorter periods, the kinds of things that we have intuition about. Yeah. Thank you for part of the torture treatment. As I was saying, my earlier career was really built around studying the natural fluctuations in the shorter period climate, the sorts of things that we're witnessing this year versus last year, and the kinds of things we saw in 1982, 83, and 1997, 98, big El Niños and so forth. And I guess I would have to say that a dozen years or so, I was a little bit of a climate change or global climate warming skeptic. I had sort of, you might say, grown up in a scientific culture that looked at natural fluctuations. We saw what I thought were big variations, and those were all contained within the natural modes and processes of the Earth's climate. But as evidence, a cascade of evidence from different sources has been produced, it's quite clear, such as the graph that Ralph just showed, that humans have altered the atmosphere. It's undeniable that the increase that Ralph showed in CO2 is caused by fossil fuel burning. That's labeled, and it can be detected by geochemists such as Ralph. And we also know that there's a number of effects that have arisen along with this that have the fingerprint of global climate change that have been occurring. So fast forwarding to where I am now, I still look at natural climate variability. I'm still interested in El Niños and seasonal fluctuations and even storm scale events. But a lot of my work is aimed at trying to understand the regional vulnerabilities and potential impacts of climate change here in the West, and in particular California. It turns out that we live in a very volatile climate in a lot of ways. The amount of variability from year to year in our precipitation, for example, here in Southern California is greater than just about anywhere else in the continental United States. So we live on the edge of a regime that can either give us real ample water in wintertime or not, with the large Pacific high sitting offshore that sometimes wards off storms and sometimes it collapses, and we get strong cyclones that travel along the westerlies and so on. And furthermore, we only have a rather narrow seasonal window for precipitation to occur, that is between about November and March, and the bulk of our water supply is derived from that season. So what that means is that we are vulnerable to rather subtle changes in climate, and furthermore, a lot of our water supply in the West is derived from not the water that's captured in the built reservoir system, but the water that's captured in the snowpack. And because of that, if climate changes positively, that is warming by just a couple of degrees, it really upsets the whole water resource management strategy in our area, and it really is a conundrum for water resources. And we're, as a community, we are looking at that scientifically, and water managers are coming to grips with how they will try to deal with this. You know, when you think about this climate change problem, it's really interesting in that the potential impacts are absolutely enormous. Most of which we in this forum won't be able to see. We won't live to see them. But we are almost unmistakably seeing the early signs right now of these. But because we aren't able to see in our lifetimes the full scope of the ramifications of the increases that will continue to occur in the greenhouse gases in the atmosphere. And one of the problems with the greenhouse loading in the atmosphere is that CO2 and other greenhouse gases don't rain out. They don't wash out rapidly like particles do. So they have lifetimes of decades to centuries. And this is like accumulating credit card debt. You know, the problem compounds over time, and that's what climate models tell us. Virtually every climate model forced by reasonable scenarios of greenhouse gas loadings over the next century warm. The amount of warming varies quite considerably, but indeed they all warm, and even were we to be able to curtail greenhouse gas emissions from the anthropogenic, the human-caused loadings that we have today, the Earth would still warm. It would continue to warm because we are out of balance radiatively. Greenhouse gases are not transparent to the radiation that escapes from the Earth's surface, so the Earth is warming up in order to achieve a new equilibrium, and that hasn't happened yet. So this all sets up kind of a conundrum societally. Climate science is in some ways it's complicated, and it's difficult for people that aren't in the field to see all of the mechanisms and the physics and so forth, and they're asked to trust predictions that are made on computers, and we all know that you know, those are just representations, and different models vary and so forth. So there's not an answer. There's sort of an ensemble of potential answers, and we're trying to understand out of all of those potential solutions what may happen. But it's pretty clear that when you look at all those swarms of potential solutions, that we will continue to warm, and the impacts will probably continue, but we're sort of having to take this on the logic that's derived from not only looking at what's happening today, but looking at what's projected on using the mechanism of So I think that makes it difficult. We haven't seen, such as we had in the El Niños and so forth, we didn't see the ups and the downs and so forth. We don't have that in our intuition. So it's one of those problems that is sort of set up for controversy, and I think that's part of what we're all here tonight to discuss. So probably that's where I should stop, and Mike, you want to take over?
Maybe for perfect symmetry, three-way symmetry, does anybody have any